I think we still have tremendous opportunity to continue to grow our ICE vehicles. We have 8 new SUVs coming out next year that are going to either be all new or refreshed.
Since Karl Benz invented the first car called the Benz Patent Motorwagen in 1885, the automobile industry has grown by leaps and bounds. Nowadays, there are so many car manufacturing companies competing for supremacy. Recently, the CEO of General Motors has made an announcement that might just destroy the entire car industry.
We had a constraint with modules. We have addressed that. We're on track for the first month, and by the middle of the year, that should be well behind us.
Their latest engine is said to have the potential to change everything about car transportation. What powers might this new engine have to cause such a drastic change? Join us as we reveal all you need to know about the new GM engine that will destroy the entire car industry. The new engine from GM. With its new compressed air engine, General Motors has taken a big step forward. It's unlike anything else the car business has seen in the last few years. It might look like a normal engine at first glance, but it works in a completely different way. This engine doesn't use fuel or electricity. It runs on compressed air. GM thinks this new idea could change the way we think about transportation, especially as people around the world look for cheaper and cleaner options for regular cars. It's surprising how easy the idea behind this engine is. High-pressure air is compressed and held, and then it is slowly let out to power the engine. A device called a pneumatic engine does this. It works a lot like a regular internal combustion engine, with pistons, but instead of an explosion, air under pressure is pumped into the cylinder to move the pistons. It gets even more interesting. If you raise the air pressure, it moves the piston outward. A spring attached to the piston pulls it back into place when the air is let out. The car moves back and forth, and the cycle ends without any fuel being used. This design isn't just neat, it works well and doesn't cost too much. The engine doesn't put out any pollution because it doesn't need oil or diesel. It also doesn't take any rare or expensive materials to make compressed air, unlike the materials used to make batteries for electric cars. GM's plan could make this technology easier for people all over the world to get and cheaper for them to buy. This technology has been around for longer than you might think. In the 1800s, people first tried using compressed air engines. They were even used in mine trains and some European city trams. But over time, internal combustion engines took over because they could provide power more quickly. Compressed air technology didn't come back until the early 2010s, when a French company started exploring hybrid engines that used both compressed air and more traditional designs. Even though those ideas didn't catch on with many people, they interested GM, who wanted to bring the idea back to life and make it better. The way that GM's new engine has been improved to meet current needs is what makes it stand out. Because the design is so much like internal combustion engines, it can be made with tools and methods that are already in use. This speeds up the development process. At the same time, the compressed air system gets rid of many of the problems that come with older engine types. This engine doesn't burn fuel at all, so it doesn't have to deal with the waste and smog that come with that. It also doesn't have the high prices and resource problems that come with batteries for electric cars, which makes it a strong competitor in the market today. The engine is new in and of itself, and it also fits right in with GM's bigger plans. The business has been putting a lot of money into environmentally friendly products, like electric cars. Rather than focusing on just one solution, GM is looking into a number of ways to cut down on pollution and make the company more efficient. The compressed air engine is another piece of that puzzle, giving people another choice besides EVs. By working on this technology, GM is setting itself up to be a leader in new ideas and ready to meet the needs of a world market that is very diverse. GM is putting a lot of money into the idea that compressed air technology can be used instead of both gas engines and electric cars. Let's take a look at the benefits of this engine and how it is set to revolutionize the car industry, because you won't believe the extent it has gone to do this. The benefits of the compressed air engine. This brand new compressed air engine looks like it will be a big deal, and not just for the auto industry. The first great thing about this engine is that it doesn't pollute the environment at all. Unlike gas or diesel engines, it doesn't pollute the air with dangerous fumes and doesn't need to burn fossil fuels. This alone makes it a very appealing choice for people who care about the environment. When you compare it to electric cars, the environmental benefits are even greater. EVs don't cause pollution when they're driving, but the energy they use often comes from grids that are powered by fossil fuels. It's also hard to make EV batteries because you have to mine for rare earth materials. These things can be bad for the earth. All of that doesn't matter with engines that use compressed air. They run on air, and the process of pressing the air down can even be driven by clean energy sources like the sun or wind. It's better for the environment this way. This engine also does a great job when it comes to price. Putting together a compressed air engine is cheaper than putting together an ICE or an EV motor. Why? This is because compressed air engines don't need as many solid materials as combustion engines do because they work at lower pressures. The metals that are used can be simpler and less expensive, which lowers the cost of production. Because of this, car companies can make cars that are not only cheap to make, but also cheap to sell. Another big plus is that the engine is very simple to design and build. Less wear and tear over time means less maintenance costs, because there are fewer moving parts. That means cars will have to go to the mechanic less often and require fewer repairs. Then there's how versatile it is. Small passenger cars aren't the only ones that can use compressed air engines. They can be used in many types of cars, from small city cars to big trucks or business vehicles. Because the technology is so adaptable, it can be used for a wide range of purposes, from personal transportation to heavy-duty tasks. This means that customers have more options and can find solutions that fit their needs. Another easy benefit is refueling or charging these cars. You're not connecting to the grid or stopping at a gas station. You're just squeezing air together. Renewable energy can be used to power the tools needed to do this. To put gas in your car, you could use completely clean energy. This is a big deal for regions moving away from fossil fuels and investing in sustainable infrastructure. There is a useful side to this technology that can't be ignored, in addition to the environmental and economic benefits. The compressed air engine is easier to build and maintain, which could be helpful in poor countries that don't have easy access to high-tech tools. This engine could help bring cheap, eco-friendly cars to markets that have been left behind by the EV boom by getting rid of the need for complicated manufacturing processes and expensive materials. Another big benefit is that it is reliable. It's less likely to break if there aren't many parts. People who drive these engines would find that they last longer and need less maintenance than other engines. The switch to compressed air engines is also in line with how energy is being made around the world. As more countries put money into green energy, it becomes easier to charge cars with wind, solar, or hydropower. In the future, when renewable energy is the rule instead of the exception, this technology will be indispensable. GM isn't just betting on a new kind of car when it uses this engine, it's also betting on a whole new way of thinking about energy and transportation. Last but not least, the price of these engines isn't just about how much they cost to make, it's also about how easy they are to get. Lower costs of making cars mean lower prices at the store, which could help people who normally wouldn't be able to afford one buy one. The compressed air engine has some promise, but it also has some challenges, as you'll see. The challenges of the compressed air engine. One of the main problems of this engine is how powerful and useful it is. Because it doesn't hold as much energy as standard fuels like gasoline, compressed air isn't very powerful. Early prototypes had trouble meeting the speed needs of daily driving, and most of them could only go about 90 miles. People who depend on their cars for longer trips or unpredictable plans can't use that kind of range. The power of the engine is another problem. For those who don't know, torque is the force that helps a car speed up and go up and down hills. Compressed air engines don't produce a lot of power because they work with low pressure. Because of this, they are not as suitable for some types of cars, especially bigger ones like buses and trucks. If these engines don't have enough speed, they can feel slow and weak, which won't make potential users feel satisfied. There's also the matter of safety. It's not as easy as it sounds to store high-pressure compressed air. Traditional steel tanks that were used in some versions are heavy and can be dangerous if they get broken. When the tank is under pressure, damage can be very scary for both the driver and people close. Even though GM has been working on better and more efficient ways to store compressed air, like making the tanks out of new materials, people still need to be persuaded that compressed air is a safe choice. Temperature is another worry. It takes a lot of heat to compress air, and it cools down very quickly when that air expands in the engine. This can cause problems like frost building on some parts of the engine, which slows it down and might even damage it over time. To handle these changes in temperature, the engine needs more systems, which makes it more complicated and costs more. These issues have been dealt with head-on by GM. High-pressure air tanks made by the company make the energy density higher. This gives the engine more power and a longer range. The new materials used to make these tanks make them lighter and safer than older ones. The goal is to find a good balance between safety, efficiency, and price, and the business has already come a long way toward this goal. GM has been working on improving the design of the engine to fix the power problem. They're trying out new setups that make more power without lowering efficiency. Based on early reports, these changes seem to be making the engine work more like traditional combustion engines, which is a hopeful sign. Better materials and industrial methods are also making things last longer. GM wants to reduce wear and increase the engine's life by using parts that are stronger but lighter. To solve the problem of worn-out parts, they are also investing in new ways to lubricate them. These ideas could make compressed air engines more dependable and less difficult to maintain, which would help build trust with customers. Concerning safety, GM knows the importance of public perception. The business is spending money on research to make sure that its high-pressure tanks are the safest possible. They're also trying to calm people's fears and boost trust in this new technology by teaching people about the safety measures that are in place. Why isn't this engine out there already? The answer is due to how long it takes to make the technology work better and make more of them. GM does not want to release a product that is not ready for the real world. They are putting the engine through a lot of tests and making changes to make sure it can handle everything from city traffic to high speeds on the highway. The business is also putting together the infrastructure that compressed air cars will need. For the engine to work, there will need to be a lot of refueling places, or in this case, charging stations. Renewable energy providers and GM are working together to make a system that is both efficient and good for the Earth. GM thinks the compressed air engine could be on the market in a few years, as long as the last few problems are fixed. Toyota, known for its diverse approach to emissions-free transportation, is actively exploring a combination of alternative fuels and traditional electric vehicles. In addition to their hydrogen fuel cell vehicles like the Mirai, Toyota is also experimenting with hydrogen-powered combustion engines. Their participation in various motorsport events to test and evaluate this technology demonstrates their interest. Toyota's forward-looking approach and investment in GAC indicate that they may adopt ammonia-powered engines in markets like China and potentially expand their use to other regions as the technology improves. While challenges remain, the continuous improvements in ammonia engine technology and the strategic involvement of major players like Toyota suggest a future where cleaner and more sustainable transportation options could become a reality. While there may be critics who doubt the viability of ammonia-powered cars, companies like GAC and Toyota remain optimistic about their potential. According to Bloomberg NEF analyst Colin McCarricker, it probably won't take off. Ammonia is hellish to handle, he said. I can't see it taking off in passenger cars. Why are critics skeptical about this innovation? Ammonia-powered cars have long been a topic of interest in the automotive industry due to their potential as a clean and practical alternative to fossil fuel-powered vehicles. However, despite the promise they hold, several key reasons have prevented the widespread adoption of ammonia as a fuel source. One of the major hurdles for ammonia-powered cars has been the lack of infrastructure. Unlike gasoline or diesel, ammonia is not readily available at conventional gas stations. Creating a distribution network for ammonia fuel would require significant investment in storage, transportation, and dispensing facilities. This lack of infrastructure has hindered the development and adoption of ammonia-powered vehicles, as consumers have limited access to refueling options. Another challenge with ammonia as a fuel is its toxicity. Ammonia is a corrosive substance and can be harmful to humans if not handled properly. This poses safety concerns, particularly in the event of leaks or accidents involving ammonia-powered vehicles. Ensuring the safe handling and storage of ammonia fuel would be critical to its widespread use, and the development of appropriate safety measures and protocols would be necessary to address these concerns. Furthermore, ammonia-powered cars face technical challenges that have impeded their progress. One significant obstacle is the combustion characteristics of ammonia. Ammonia has a different combustion profile compared to conventional fuels, requiring modifications to engine designs and fuel systems. It has a lower energy density compared to gasoline or diesel, which means larger volumes of ammonia would be needed to achieve similar performance levels. This poses challenges in terms of packaging and range limitations, as the larger fuel storage tanks would occupy more space and add weight to the vehicle. Additionally, the conversion of existing internal combustion engines to run on ammonia is not a straightforward process. Engine modifications are needed to accommodate the specific requirements of ammonia combustion, such as changes to fuel injectors, combustion chambers, and exhaust systems. These modifications would require significant research and development, as well as testing to ensure the performance, efficiency, and durability of the converted engines. Another factor that has hindered the development of ammonia-powered cars is the availability of alternative technologies. Over the years, other clean energy options, such as electric vehicles, EVs, and hydrogen fuel cell vehicles, have gained prominence and received significant investments. These technologies have been further developed and have seen improvements in terms of infrastructure, battery technology, and overall performance. As a result, the focus and resources have been primarily directed toward these alternatives, leaving ammonia-powered cars with limited attention and investment. Moreover, the production of ammonia itself poses environmental challenges. Currently, the majority of ammonia production relies on fossil fuel-based processes, such as steam methane reforming. This leads to greenhouse gas emissions, contributing to climate change. To fully realize the environmental benefits of ammonia-powered cars, it would be necessary to transition to more sustainable and carbon-neutral methods of ammonia production, such as electrolysis powered by renewable energy sources. However, the development and scaling up of these sustainable production methods are still in progress, adding to the complexity of adopting ammonia as a mainstream fuel. Lastly, the regulatory landscape has also played a role in the slow progress of ammonia-powered cars. Governments and regulatory bodies have primarily focused on promoting electric vehicles and hydrogen fuel cell vehicles as part of their clean transportation strategies. As a result, the regulatory frameworks and incentives have been more favorable towards these technologies, leaving ammonia-powered cars with limited policy support and incentives. But the dream of an ammonia-powered engine taking over the automobile landscape is very possible. Why? Why is ammonia worth the effort? Ammonia engines have a standout feature that sets them apart: high energy density. This means that a significant amount of energy can be stored within a given volume of ammonia. This characteristic is crucial for efficient energy storage and transportation, making ammonia engines particularly well-suited for sectors like transportation and power generation, where effective energy storage and utilization are of utmost importance. One of the compelling advantages of ammonia engines is their reliance on widely available resources. Ammonia can be produced from various elements, such as hydrogen and nitrogen, which are abundant constituents in the Earth's atmosphere. This accessibility underscores the viability of ammonia engines as a sustainable energy solution. By utilizing readily available resources, we not only have the potential to reduce carbon emissions, but also to develop more resilient and flexible energy solutions. What's interesting to note is that ammonia has played pivotal roles in various industrial settings throughout history. For instance, its use in refrigeration during the 19th century revolutionized food preservation and storage. During World War I, ammonia became a vital component in the production of explosives. In the mid-20th century, ammonia drove the growth of the chemical industry, enabling the manufacturing of synthetic fibers and plastics. In the field of agriculture, Ammonia-based fertilizers sparked a global revolution in food production. Moreover, ammonia continues to be indispensable in industries such as cleaning products and pharmaceuticals. Toyota's CEO, Koji Sato, envisions a groundbreaking future for ammonia in car engines, with a focus on low CO2 emissions. This vision of ammonia-powered engines opens up possibilities that could potentially revolutionize the automotive industry, and may even challenge the dominance of electric vehicles, EVs. Why is China doubling down on ammonia-powered cars? And how is that connected to growing interest in low CO2 emission engines across the world? China boasts the largest electric vehicle market in the world. However, there is still a strong demand for traditional combustion engine cars. Nevertheless, there are indications that the Chinese government is contemplating a ban on the sale of internal combustion engine vehicles, following a trend similar to the policies implemented in California. This potential development could present a tremendous opportunity for the emergence of ammonia-powered vehicles, which have the potential to provide a low-carbon and cost-effective solution for the Chinese market. Not only would ammonia-powered vehicles reduce China's reliance on oil imports, but they could also significantly decrease air pollution levels in the country. If China becomes a leader in the adoption of ammonia-powered vehicles, it could set an example for the rest of the world. Exploring alternative fuels such as hydrogen, ammonia, and synthetic fuels could breathe new life into combustion engines. These innovative fuel options may even become more affordable to produce than fully electric vehicles in the future, offering a compelling and eco-friendly choice for a broader range of consumers. Moreover, by addressing concerns about convenience, Toyota has established a solid position in the Chinese market by developing customized EVs for this region. The company's strategic approach demonstrates a commitment to meeting diverse consumer preferences. Toyota's exploration of technologies like the ammonia-powered engine aligns with this comprehensive strategy. It will be captivating to witness the progress of this technology and whether it will eventually become commercially available on a global scale. Considering China's evolving automotive landscape, the potential integration of alternative fuel-powered vehicles, such as those utilizing ammonia, adds an exciting dimension to the ongoing transition toward more sustainable transportation options. Ammonia-powered vehicles have the potential to reduce greenhouse gas emissions, decrease oil dependence, and improve air quality not only in China but also beyond its borders. While GAC and Toyota's ammonia engine development efforts are impressive, it is worth noting that they are not the first to explore this area. About a decade ago, the Korean Institute for Energy Research made significant advancements by creating a vehicle called the AMV. This innovative car utilized a mixture of 70% ammonia and 30% gasoline, resulting in a remarkable 70% reduction in carbon emissions. The AMV project aimed to explore the possibility of a fully ammonia-fueled engine, demonstrating the feasibility of this technology. However, it is important to mention that GAC's engine also appears to produce some carbon dioxide. The company was only able to achieve a 90% reduction in carbon emissions, suggesting the use of another fuel source in the engine's design. This hybrid approach could be a practical solution, considering the properties of ammonia, such as its relatively slow flame propagation speed, which can present challenges for engines operating at high RPMs or low loads. By combining ammonia with another fuel, the GAC engine may have effectively overcome these challenges, ensuring smoother and more versatile performance across various driving conditions. This hybrid approach has the potential to enhance the engine's practicality and usability. Numerous projects have approached ammonia-fueled engines from different angles, all highlighting the ongoing efforts to harness ammonia's potential as a cleaner and more sustainable fuel source for combustion engines. As this field continues to develop, further innovations and optimizations will likely contribute to achieving environmentally friendly transportation goals. Ammonia engines have the potential to offer a low-carbon and cost-effective alternative to fossil fuels, reducing reliance on oil imports and improving air pollution levels not only in China but also globally. Nowadays, vehicles face a plethora of challenges that have an impact on both the environment and the customers who rely on them for their daily transportation needs. When it comes to choosing a vehicle, customers are faced with a multitude of options, each promising convenience, style, and efficiency. However, beneath the attractive exteriors and advanced features, there are significant challenges that affect our relationship with automobiles. One of the most prevalent challenges modern vehicles face is our ongoing dependence on gasoline. For decades, gasoline has powered our cars and propelled us forward, but its impact on the environment is undeniably concerning. When gasoline burns in the internal combustion engines of our vehicles, it releases a multitude of pollutants into the air, contributing significantly to the global environmental crisis we are currently facing. Just picture this. As you drive your car, fueled by gasoline, it emits carbon dioxide, CO2, into the atmosphere. This infamous greenhouse gas traps heat, leading to climate change and unpredictable weather patterns. But that's not the only toll on the environment. Gasoline combustion also releases nitrogen oxides, NOx, and particulate matter, which degrade air quality and pose health risks for humans. Our continued reliance on gasoline not only perpetuates our carbon footprint, but also raises concerns about the long-term sustainability of our transportation choices. In response to these urgent environmental concerns, we are witnessing the remarkable rise of electric vehicles, EVs, as a promising alternative. The appeal of zero-emission driving and a departure from traditional gasoline-powered engines position EVs as an environmentally friendly solution. However, this shift is not without its own set of challenges, particularly in terms of affordability and maintenance. Affordability poses a significant barrier to the widespread adoption of electric vehicles. Despite technological advancements that have gradually reduced the cost of batteries, a crucial component of EVs, the initial price tag of electric vehicles remains higher compared to their gasoline counterparts. This upfront cost can discourage many consumers, even though there is potential for long-term savings on fuel and maintenance. Maintenance adds another layer of complexity to the realm of electric vehicles. The intricate nature of electric drivetrains and battery systems requires specialized knowledge for repairs. Not all local garages are equipped to handle electric vehicle maintenance, leading to increased costs and inconvenience for EV owners. Furthermore, questions loom about the longevity and performance of electric vehicle batteries, raising concerns about the environmental impact of their disposal. While electric vehicles offer a greener alternative, they also bring about their own environmental challenges. Battery production relies on rare and environmentally impactful materials, questioning the overall sustainability of EVs. Additionally, the recycling and disposal of used batteries present challenges, as the infrastructure for handling electric vehicle waste is still in its early stages of development. The growing interest in developing car engines with low CO2 emissions stems from a pressing need to mitigate the adverse effects of climate change and reduce greenhouse gas emissions. This imperative has led to a significant shift in the automotive industry, as manufacturers, policymakers, and consumers alike recognize the urgency of transitioning to more sustainable transportation solutions. One key driver behind the push for low CO2 emissions is the alarming rise in global temperatures and the subsequent impacts on the environment. The burning of fossil fuels, such as gasoline and diesel, releases vast amounts of carbon dioxide into the atmosphere, trapping heat and contributing to the greenhouse effect. This phenomenon has caused a range of detrimental consequences, including rising sea levels, more frequent and severe natural disasters, and the disruption of ecosystems. Developing car engines with low CO2 emissions is thus crucial to limit the exacerbation of these effects and ensure a sustainable future. Additionally, reducing CO2 emissions from car engines is essential for improving air quality and public health. Combustion engines release not only CO2, but also other pollutants such as nitrogen oxides, NOx, particulate matter, PM, and volatile organic compounds, VOCs. These pollutants are known to have adverse effects on respiratory health, contributing to the onset and exacerbation of respiratory diseases such as asthma and chronic obstructive pulmonary disease, COPD. By developing engines with low CO2 emissions, the automotive industry aims to reduce not only the primary greenhouse gas responsible for climate change, but also the harmful pollutants that directly affect human health. Furthermore, the interest in low CO2 emissions arises from the need to achieve energy independence and reduce reliance on finite fossil fuel resources. The transportation sector heavily relies on petroleum-based fuels, which are finite and subject to price volatility due to geopolitical factors. Developing car engines that emit less CO2 promotes the adoption of alternative fuels and technologies, such as electric vehicles, EVs, hydrogen fuel cells, and biofuels. These alternatives offer the potential for greater energy efficiency and the use of renewable energy sources, reducing the dependence on fossil fuels and enhancing energy security. The push for low CO2 emissions in car engines is also driven by regulatory frameworks implemented by governments worldwide. Governments recognize the urgency of addressing climate change and have implemented various policies to encourage the development and adoption of low-emission vehicles. These policies include emissions standards, tax incentives, and subsidies for eco-friendly vehicles. By complying with these regulations and meeting the growing demand for sustainable transportation, automakers can ensure their competitiveness in the market and avoid potential penalties or reputational damage. Moreover, consumer demand plays a significant role in driving the interest in developing car engines with low CO2 emissions. Increasingly, consumers are becoming more environmentally conscious and prioritize sustainability in their purchasing decisions. As awareness of the impacts of climate change grows, consumers seek vehicles that align with their values and have minimal environmental footprints. Automakers recognize this shift in consumer preferences and are investing heavily in research and development to meet the demand for low-emission vehicles. By offering a range of options with low CO2 emissions, automakers can attract environmentally conscious consumers and gain a competitive edge in the market. The urgency to address the adverse effects of greenhouse gas emissions and transition to sustainable transportation solutions has prompted significant investments in research and development within the automotive industry. By reducing CO2 emissions from car engines, manufacturers can contribute to a more sustainable future, safeguard public health, and ensure the long-term viability of the transportation sector. Thanks for watching. While you're still here, click on the other videos you see on your screen right now